essentially 2 buckets of the wood mix to 1 bucket of biosolids. Plus we add a bit of ashen that we get from Tolko, which helps with our carbon content and odor, slightly with the odor issues. And in the summertime, the wood dries out, and we add about 1,000 kilograms of water to each batch. And that's about that.
Most of your wood waste is coming from Gorman Brothers in West Bank? Or?
I'm not sure exactly where it's coming from all the time. Most of it we get hog fuel brought in by DCT, which comes from generally Tolko, but I think just about anywhere they can get it.
Marcy was just saying this morning that like the supply of wood waste is really unpredictable.
It is, yeah.
One day they're told there's nothing, and in Armstrong there's a cogeneration plant, and they take as much wood waste as they can to create energy. So,
and they've been working on trades with the landfill to trade whitewood, ground whitewood from the landfill and send it to Tolko for their cogen, so we can get hog fuel, which, well, Gord Light would be able to fill you in better on that, but it's been a tricky business to keep a solid supply. But yeah, we also get the odd load of pruning waste that's ground up at the landfill and brought here. We get various logging outfits will bring in, if they've got a few loads of cedar or something else, they'll bring it in. Get Christmas tree waste from Vernon.
So there's no specific type of wood you want?
Well, preferably if we could have the Chambers hog fuel all the time, we would go with that. It seems to be the best, but it's also in high demand and it's expensive for us to buy. So I think we pay about $70 a load, I think, and we get on average 3 loads a day. I could be wrong; it might be higher, but a fairly high operating costs for what we're doing, mostly with trucking. So anyways, once it's been mixed, close that. Once it's been mixed, it moves out onto the primary area. So you can see here, here's a pile that hasn't been covered yet. Comes out, sits on these aerated channels. There's quarter-inch, maybe not even quarter-inch holes in these channels, side by side on each one. And it's can't remember the volumes of the air, but it's a low-pressure, high-volume system. So we push vast amounts of air through, draw it back down as well. We cover the primary mix with various things. Usually, we used to do our overs from our screening. Then we switched to finished product, and now we've ground all of our overs, and we're using that. Cuts down on odors to a certain degree, and primarily it's an insulating layer, keeps the piles warm. And you can see the flag, some of these flags sticking out, those are the probes. You can see the ones hanging up on the wall there. It sits here for 27 days or more. It's got to reach certain temperatures for certain lengths of time to be able to move on. If it doesn't reach its third regime of temperature, it won't go on. It'll either go back into the mix or be mixed up, put back onto primary. What are the temperature regimes? We have to reach PFRP, which is process to further reduce pathogens. That one, I believe, is 60 degrees for 14 days. And we've also got the VAR, which is vector attraction reduction, which we have to meet 50 degrees for at least 3 days.
What was the first one?
Process to further reduce pathogens. And is, I believe, 50 degrees for 3 days. If it passes those, it reaches regime 3, and we can move it on to secondary, which, we're required to have the compost on air for, I believe it's 55 days, meeting these temperature requirements. So essentially, if it's met it here, essentially on secondary behind you turns into more of a curing stage.
How does the aeration system work?
I'm sorry?
The aerator, how does it work?
I'll take you behind you guys, either over here or behind the wall in a little while, and you see the big fans. And,
Okay.
Yeah. So I guess we'll skip walking down primary because it is going to be mucky and gross, and that ash doesn't come off the clothing. So, is this the ash?